Hi guys, welcome to this tutorial. Now today we're going to be starting a new case study. By now you would have finished the course, and you would have perhaps looked at the first case study that we did, which was a very simple residential house, a bungalow. You would have perhaps practiced that. And with this case study, we are going to tackle a slightly more complex project. This time, it's a two-story house, terraced houses, and we will go through and draw the scheme as a case study, the same way that we have done with the a single-story building. Obviously, so that you can look at all the concepts that you have learned, remind you of what you have learned, and then we'll introduce more complex concepts as we go. Now, the format for this is that I intend to release this course as I go. So in a sense, it will be released over a period of time. So as we develop the project, it will be released, and you can see or go through the projects as it's ready. Depending on time, what I was hoping to do, perhaps at the end, is to move this along as well, and perhaps try introduce students to rendering as well, using 3D Studio Max, which is my workflow. In the tutorials, I said that my workflow is AutoCAD, Revit, 3D Studio Max, Photoshop. So I'll hope to bring some elements of 3D Studio Max and Photoshop, hopefully in this project. If not this project, then obviously the next one. But we'll see how we do for time. Now, in this particular tutorial for today, we will look at importing from AutoCAD into Revit, and once we've got the drawing into Revit, we will then begin to work on the drawing, using the imported drawing from AutoCAD as our guide. Okay, so we will start now. In front of you is your normal screen when you get into Revit. What we're looking for, which I've already set up, is we're going to use the architectural template. I've already set up a sheet which you can see the Terraced family house. Like you all know by now, you just go to projects, either you go to new and then find architectural template, or you just go to projects and then architectural template. So if I open the scheme that I've just set up, again, from the tutorials, you know, if you set your desktop this way so that your project browser, you only need to drag it. Normally, when it opens, when you open it on on Revit, the first time it's on your left. I prefer to drag it to the right, and then have then you can have your drawing very clear at the center. So that is our starting point. Now we are in Revit. If I I'll show you what we're going to be bringing in. If we first of all go to AutoCAD, we'll be bringing this drawing in. You can see it's already drawn out in AutoCAD. It doesn't have to be with Revit. In fact, this is double handling. It just does not have to be. You can work straight from Revit, but there are sometimes maybe in some offices maybe some people would have done some drawings in AutoCAD. Then you can use this as backing to model in Revit. So that's where we are. So this is a drawing that's been done on AutoCAD, and it's really to import this into Revit. So if I minimize this drawing, and then we're back in Revit. So where I need to go to Insert, and you can see where it says Import CAD. Now if I click on Import, now you can find on your system where the drawing is. In this case, that's my drawing there. And then there are some options that you've got to select at the bottom here. I don't want any colors to come, or the AutoCAD colors to come in, so I just click on that and say black and white. Layers and levels, all of them, that is fine. Import units, auto detect. I always find sometimes that makes a mistake. So if you just click on it, the AutoCAD drawing is in millimeters. Just tell it that it's millimeters, then it takes that. Auto center to center. I'll just go from origin to. I'll just go to origin. That way I can, if I wanted to import other drawings, I'll just use that rather than center to center. Right. I think that's all on this particular view, and if I say open, whoa, it will just load. It is somewhere at the origin. There it is. You can see because I didn't do center to center, obviously it's left my elevation markers here. So all I need to do is to pick them up and just move one there so I can see my project. Let's pick up the second one and just move it up there. I'll pick up the third one. I'll place it here where I know it's I can find it, and then that one I'll just put it there. Now I can see all the views or all the elevations of my project by placing them around the site itself. If I zoom in a bit, you can see there's the drawing that was done on AutoCAD, which I will be looking to draw over. Now there are some things I would like to set up first of all before moving on. And the first one is obviously to look at the levels, make sure they are correct. Normally Revit defaults to about 4 meters. These are residential houses, and the floor to floor is approximately 2.8 meters, so we will rectify that shortly. So and the way to do that, as you would have learnt in the study tutorials, is to go to elevation. You can pick up any of the elevations. For instance, as the east one, east elevation, pretty much nothing showing. Just click on that, you can find it's there. What I normally would do is to obviously see how much of it is available. Right. Okay, because of the size of the screen, I'm having some slight difficulty putting that down because it's going up. I just wanted to take 1, 2, and 3, and then I want to remove this click without line, and just say no clip at all, and just say OK. Now you can see more of my elevations. If I click on that, you see these dots. All you need to do is to shift them a bit. Use the lower one to shift it up. And I haven't drawn anything yet, so there is no elevation to really see or there. But if I just want to give it some space, you can see my my levels here. That is now showing. So that was what I meant. You see level 0 there, and then there is the level 1, which is at 4 meters. If I click on that again and change that to 2800, that's 2.8 meters. I work in millimeters. If you remember, we imported in millimeters, so it's 2800 millimeters. And if we do enter, then the next thing is to do the second level. So this is the ground floor. Then this is the first floor. If we go to architecture, and then you see levels there. So if you click on level, then just follow the guideline to align it. You can see that guideline just go in there. So if you just take it up until it is 2800 millimeters, or if you prefer, you can just type 2800. The same thing would happen. So it's showing 2800 there. So I will just click, that is left mouse click, and then release. Just drag along until it aligns with the other side, and then just click, and that's level 2. So obviously we've got a ground floor, first floor, then this is where we will draw our roof, or the roof level, which is level 2. So that is done. Really, you can go to I'll just escape to come out of the command, because you can see it wants to draw more, but all you do is to escape, and you come out of that command. You can go to the other elevations, and the north, the south, and the west, and repeat. No, you don't need to repeat. All you need to do is just set it up so you can see what is there. A lot of times you just have got to watch out for these extents, and then remove the far clipping to no clip to see the full extent of your elevations. And that is it. So we can now go back to level 0, where if we wish we can begin to draw or begin our project. Now there are other things I would like to set up before we proceed. I'd like to show students how to use, or how to set up the construction elements. For instance, if there are standard types that come with Revit, but you don't have to stick with those standard types. You can go or do your own. Say, for instance, you're working in an office. This building. Somebody says to you, "We want this building like in the UK. There's a target U value that you're looking for in terms of thermal insulation for energy efficiency." So you've got to modify the Revit standard types to make sure that it complies with the regulation applicable in the country that you are working. And in the UK, it's the U value. So you've got to look at what is your target U value for these walls in terms of how energy efficient you want the building to be, and then obviously set it up accordingly. So if I'd gone back into architecture and then clicked on wall, that's the basic wall type. Imagine I want to use cavity wall here. That one is 102.75 insulation 100. Let me see. I can select a different one. Let's go with this one. I like this one because it's got 102 for the brick, 50 mil air space, and then 45-inch insulation and 100 block on the inside. Okay, let's use this now. So that is what we want to use. So I think at this point, let me move away from Revit a bit, because I know some people may have this problem, perhaps in the office. They'll say, okay, fine, how do we do this? If you use your U value calculator, I'll get one that I sometimes use. It's a manufacturer's U value calculator. I'll just find it on my desktop. Right. So say for walls, we're looking there to use cavity insulation with plastable thermal laminates. So if I click on that and say continue, what sort of fix is it? Plastable dot and dab, that is fine. I'll say continue. I'm just going to do this very quickly, just so that some people, some students can appreciate sometimes, I mean, how they relate in terms of putting those walls in. So you've got external finish. There's no external finish. The outer leaf is brickwork. The outer leaf thickness 103 millimeters, fine. 55 mil clear cavity. Low emissivity, that is fine. If you remember, this is how we're building this up here, because we'll go back and build this in Revit. Cellotex insulation, no, we'll just give it a target U value of 0.18 for the wall. That's a very good U value. I know currently there's a code for sustainable homes. You're supposed to really have good U values. Passive house perhaps maybe even better, but let's go with 0.18 for now. The internal, let's use I'm not recommending any manufacturer here by any means, but these are, you can select whichever manufacturer will do the job. Obviously, structurally you've got to talk to your structural engineer. And then inner leaf thickness, say 120, 120 millimeters. The dabs on the inside, let's go with 49 mil on the inside face of the blockwork. Board joint seal, VCL, air leakage barrier, plaster, light scheme, that is all fine. So you ask it to calculate U value, and you can see that we are hitting our U value with that of 0.18 W m square K. So what it's giving us is 41 millimeters insulation of this particular product. I'm not in any way recommending any particular product. It is down to individuals to see what works for them. So I'm going to now put what we have just done into Revit to make sure this is the U-value target for this particular wall. This is the performance we're looking for in terms of energy for this particular wall. And I will now go back into Revit and build my wall accordingly. So if I minimize that, here I am in Revit. Before I start, I'm going to use this as the base first of all. So I go to under Properties palette, click on Edit Type, and then you can see the type properties come up. The first thing to do is so you don't modify the standard Revit standard, just do duplicate. And then here I will name it, I'll call it U-value sorry, 0.18. Right. So if I leave that as a U value, if you remember what we did, we said it was going to be 41 insulation, and then the block work was 120, and the plasterboard we said was 49.5. So it's 49. Sorry, the insulation before the plasterboard is 49.5. And then I'll then put the plasterboard here, since I'm putting all the specification in terms of the weights there. So it's 12.5 millimeters for the plasterboard. So going from outside to inside, we've got your block work 102, airspace 50, 40-inch insulation 120. That's your load bearing block, cement concrete blocks, masonry blocks, and then you've got 49.5 mil on the inside, and then you've got your plasterboard 12.5 mil. I'll just say OK, and now I'll come here where it says structure, and I'll begin to build this. So I'll say Edit Type. Here it's got brick on the outside, which is fine. Air barrier air 50, which is absolutely fine. The fiberglass was we said was 41, so if I change that to 41, well, that's the insulation layer. The concrete masonry blocks 100, we said it was going to be 120. Sorry. Then here we were going to put a new insulation layer, thermal. I'll select thermal by category, fiberglass. Where is it? Bats, right? Okay, and say OK. And then we said that was 49.5. Right, so that is the build up. 102, 50, 41, concrete masonry blocks 120, that's the load bearing structure. Then on the inside there's a thermal insulation of 49.5 millimeters, and then the finish is is plasterboard, 12.5 millimeters. So that is our build up, and that build up gives us our U value of 0.18 as we have calculated. So I'll just say OK, and then come back here and accept that and say OK. So you can see that it has now built our wall that will meet the thermal performance that we were looking for these for the external walls of this particular project. So as you know, all I then need to do is start drawing. It's unconnected height. I would like that to stop at level 2 where our roof will be, and then you can start drawing center line. I can say the finish face of the exterior, and then I just start drawing. I think I clicked before the line. I'll just do that again. I'll undo. Right. Okay, I've got that right now. And then I can go around. And there is building wrapped up and a U value of 0.18. That's the thermal performance. If we go look at our 3D, just click the plus sign there and 3D, you see our building begin to take shape. There it is. If I just click there and just turn that around, all I've just done is clicked on a component, press down the shift key and the middle mouse and turn that to sort of circle around it. So that's our building wrapped up warmly to U value, to a thermal performance of 0.18. I'll bring this particular tutorial to an end. It's past 20. I didn't want to go this too far, just to keep the tutorials very short. So in this tutorial, you learned how to import drawings or layouts from AutoCAD. We learned how to build the walls and build the components. We learned how we can modify the standard components in Revit to meet the thermal performance that we want for our building. We went on then to draw the wall around our building. So our building is wrapped. Terraced houses are wrapped warm. If I may say so, are wrapped warm in a wall that is has got a U value of 0.18, which is a very good U value from judging from the current regulations. So that brings us to the end of this particular tutorial, and in the next tutorial we will continue from here.